So, from figure 5.5, which shows two conventional ways of graphically representing Boyle's law, figure 5.5 is a graph of equation 5.3 at different temperature. The value of k for curve is because of for given mass of gas, it varies only with temperature. Each curve corresponds to a different constant. Temperature and is known as isotherm. Constant temperature plot. So isotherm means any graph made at constant temperature is known as isotherm. Like this is isotherm. Because it is made at constant temperature, right? Like this complete graph is in at 200 Kelvin. This is completely in 400. This is completely in 600. Like that. Higher curves correspond to higher temperature. It should be noted that the volume of the gas doubles if the pressure is halved. So from this what we can conclude, pressure is inversely proportional to volume. Very important, it will come after this. Or we have done in the last video. Yeah, we are already done with that. If you don't know about this, then you must go and watch my previous video. Higher curve corresponds to higher temperature. It should be noted that the volume of gas doubles if pressure is halved. Table 5.1 gives the effect of pressure on volume of 0.09 mole of CO2 at 300 Kelvin. Figure 5.5 represents the graph between P and 1 by V. Look, it is a straight line because if we write it in log form, then uh, it becomes in the form of y equal to mx. When we write it in the form of log, then it becomes a straight line. Y equal to mx is a straight line. Now, however, at higher pressure, gases deviate from Boyle's laws, and under such condition, a straight line is not obtained. So the gases which do not deviate from Boyle's law. Here we are talking about deviating from Boyle's law. Which do not deviate from Boyle's law, they are known as ideal gas. Ideal gas. Right. Experiment of Boyle in a quantitative manner prove that gases are highly compressible because when given mass of gas is compressed, the same number of molecules occupy a smaller space. This means that gases become denser at higher pressure. Right? A relationship can be obtained between density and pressure by using Boyle's law. Look here, this is an important point to focus. Gases become denser at higher temperature and molecules occupy a smaller space at the if you give them this much area, 10 molecules. So now when you compress it in a smaller area, see here it is big, here it is small. So so density increases. Also molecular speed also increases as pressure increases. So yeah, so but volume decreases. Volume here is more, here is less. So that's why we also say that pressure is inversely proportional to volume. Right? A relationship can be obtained between density and pressure by using Boyle's law. By definition, density is related to mass and volume by relation. Density is equal to mass by volume. This formula is important. If we put V in this equation, from Boyle's law equation we obtain relationship. This graph you can go through personally. I'm not gonna go through this. It is important, of course. So just go through it once. Density is equal to m by k1 p k dash p. So this shows that at a constant pressure is directly proportional to the density of a fixed mass of gas. Right. Now this question you guys can do. If you want, you can write it in the comment section. I will be replying to that also. So yeah. Charles law, temperature volume relationship. Charles and Gaseous performed several experiments on gases independently to prove upon hot air balloon technology. Their investigation showed that for a fixed mass of gas at constant pressure, volume of a gas increases on increasing temperature. Volume of a gas increases on increasing temperature and decreases on cooling. So this is also important. You have to remember this. Uh, they found that volume of a gas increases on increasing temperature. The reason is that volume is directly proportional to temperature. So, like if you have a solid, right, molecules are very close. So, if you increase the pressure, what will happen? It will turn into liquid, and even if you again keep on increasing, then it will turn into gas. And you know that gas is occupying more volume than liquid and solid. That's why. So they found that for each degree rise in the temperature, volume of a gas increases by 273.15. This 1.15 is not required. So of the original volume of gas at 0 degree. Thus the volume of the gas 0 degree Celsius and at T degree Celsius are V0, Vt respectively. And then this is the final one. Look, final temperature is nothing but initial temperature plus how much temperature you are increasing. Like if you are going from 0 degree to 25 degree. Here you must take the value in degree Celsius. The reason is this formula is obtained in sense of this one. Like even if 0 degree Celsius, because if you take it into Kelvin, then at 0 degrees Celsius it will become double, because 273.15 cancel. So this formula is derived for degree Celsius only, right? The only degree Celsius. Now at a stage we can define a new scale of temperature such that 30 degrees Celsius on a new scale is given by this, and 0 degrees Celsius will be given by 273.15. You guys must be knowing it because you have already learned the conversion 0 degrees Celsius to Kelvin. For converting into Kelvin, we just add 273 to any temperature. Kelvin. 0 plus 273 gives you 273. That is, this new temperature is called Kelvin temperature scale or absolute temperature scale. We know in chemistry we have to convert to solve any numerical, we have to first convert the, if the temperature is given in Kelvin, then it is good. If it is not given, then we have to convert it into Kelvin. Otherwise, we won't get the right answer. Now, thus 0 degree Celsius scale is equal to 273.15 Kelvin at absolute scale. Note that degree sign is not used while writing temperature in absolute temperature scale. So every question is solved in absolute temperature scale, that is Kelvin scale. Kelvin scale is also called thermodynamic scale. Thermodynamic scale of temperature, and this is used for all scientific works. Thus we add 273, more precisely 273.15 to the Celsius uh, temperature to obtain pressure at Kelvin scale. Now, uh, this is not important. Sorry, this equation is important. What this says is that what this says nothing but this. You can also write it as V1 by V2 equal to T1 by T2. This U as a own you can also derive, as you know that volume is directly proportional to temperature. So V1 by T1 equal to constant and V2 by T2 equal to a constant. You can equate these both and you can get the same equation. See, you can see the complete derivation over here. The value of constant is determined by the pressure of gas. It is the amount of units in which volume is expressed. Now, in mathematical equation, is a mathematical equation written by this. One second, I'll just delete it because this is important. So, yeah. So the value of constant K2 is determined by pressure of the gas, its amount, and the units in which volume V is expressed. So let me see you in the next video because we don't have time. Otherwise, I can't upload it. Bye guys.